Welcome everyone. Imagine a world where doctors can monitor the patients in real time from anywhere using smart devices and internet. That is the power of healthcare IoT, a technology transforming hospitals, patient care, and medical monitoring systems. In today's video, we will explore the introduction and architecture of the healthcare IoT in a simple and easy to understand way. So let's dive into the smart world of connected healthcare systems. First, we'll see what is the healthcare IoT, that is healthcare Internet of Things. Here it shows how, like this image, it shows how smart healthcare devices, communication networks, then you have cloud servers, healthcare professionals, and users work together to provide better medical services and continuous health monitoring. You can see a boy, or you can treat him as a patient who is wearing a smartwatch and other medical sensors. Now, these devices represent the IoT health devices used to collect physiological information from the human body. Some examples here they are shown, that is the devices of the, that is IoT health devices, like you have smartwatch, ECG patch, then you have glucose monitor, you have pulse oximeter and blood pressure monitor. These devices continuously measure important health parameters such as heart rate, ECG, blood sugar, blood pressure, and the oxygen saturation or the oxygen level. Now, the collected data is transmitted wirelessly to this processing unit. Here, the processing unit, it is represented by a smartphone. Now, this smartphone, it acts as an intermediate device that receives the sensor data and it performs the basic processing, temporarily stores the information, and it forwards this data to the cloud. So here the smartphone, it plays an important role in connecting wearable devices with healthcare systems. Now the next component is the cloud server, which is shown here. You can see here, this is the cloud server. So the cloud server, it stores large amounts of patient data collected from multiple users, and it will perform advanced processing, data analysis, and health prediction. Now, by using the cloud computing technologies, healthcare providers can access the patient information from anywhere and at any time. Now, here you can see the doctor, he is monitoring the patient information through a computer. He is using a computer here. Now, the doctor can view the reports, then he can analyze the health data, and he can monitor the patient conditions and provide the treatment recommendations. Now, this demonstrates how healthcare IoT enables remote healthcare services without requiring patients to visit hospitals frequently. Here you can see the alerts and the notification section also. That is, when abnormal health conditions such as heart rate or low oxygen levels are detected, automatic alerts are generated. And these alerts can be sent to doctors, hospitals, then caregivers and family members, ensuring quick medical attention during the emergencies. Okay. Now, here you can see a smart hospital also. So, the hospitals, these can receive the real-time patient information and provide immediate healthcare services. Then next, you have family members who can monitor the patient's condition through the mobile phones. Okay, here, mobile phones or mobile applications, and receive updates about their loved ones' health. Then you have some healthcare applications, healthcare IoT applications, which includes the heart monitoring, then diabetes monitoring, blood pressure monitoring, elderly care, infant monitoring, and the fitness tracking. So here you can see some benefits. The major benefits are the continuous healthcare monitoring. You have remote patient care, early disease detection, emergency alerts, then reduced healthcare cost and better access to the healthcare. So here you can see that the healthcare IoT, it connects the devices, healthcare professionals and patients to improve the healthcare quality, and it saves the lives. Next, we'll see the architecture of the healthcare IoT. So here the architecture of the healthcare Internet of Things, it is divided into 4 layers. So these layers, these work together to collect the health data from the patients, process and analyze the data, and provide useful information to the doctors, hospitals, caregivers, and the patients. And this architecture, it enables continuous health monitoring, remote healthcare, and quick medical decision making. Now the first layer, it is the sensors and the data collection layer. Here it consists of various physiological sensors which are attached to the patient's body. And you can see here there are two patients, okay, wearing different sensors. Fine. So these sensors continuously measure the important health parameters such as the heart rate. Then you have like ECG signals, blood pressure, blood sugar level, body temperature, and the blood oxygen level, that is the SpO2. Now the primary purpose of this layer, it is to collect the real-time physiological data from the human body. Since the sensors are wearable and lightweight, they allow continuous monitoring without disturbing the patient's daily activities. Next, we have layer 2, that is a local processing unit, gateway or hub. So here the collected data, the collected sensor data, it is transmitted wirelessly to a local processing unit, also called as a gateway or a hub. Here, this is a local processing unit. It is also called as gateway or a hub. Now here, this layer, it is represented by a communication device and a smartphone. This is a communication device and this is a smartphone. The gateway, it receives the data from multiple sensors and performs basic processing such as processing tasks such as the filtering of noise, then organizing the data and temporary storage. Then this layer, it will act as a bridge between the sensors and the cloud infrastructure, and it ensures that only useful and meaningful information is forwarded for further analysis to the cloud. Next, layer 3, we have the cloud server and the data analytics. It contains cloud servers, then it contains the databases, analytics, tools, and after receiving the data from the local gateway, the cloud stores the large volume of patient information and it will perform advanced analysis. And here you can see the data storage, you can see database and analytics, and also that is you can see the graphical reports and the AI/ML based analytics, okay, AI and ML based analytics and the decision supports. And here machine learning and artificial intelligence techniques can identify the health patterns, predict diseases, detect abnormalities, and generate alerts. Now, since data from multiple patients can be stored together, the healthcare providers can access medical records from anywhere or any location. The fourth layer is the application and the end users. So here, this is the final layer and it represents the end users who interact with the healthcare IoT systems. These includes the doctors, then patients, then you have the caregiver members or the family members and the hospitals. The doctors can view the patient's report through the dashboards here, and patients can monitor their health using the mobile phone here, okay. And family members, they can receive the alerts using the using the mobile apps during the emergencies, and hospitals can use the information for the treatment planning and the patient management. So overall here we can see that the healthcare IoT, it creates a complete healthcare ecosystem where the sensors collect the data, then that data is sent to the local gateway where the gateways process the data, then it is sent to the cloud servers where it is analyzed and the applications deliver meaningful insights. This architecture, it improves health care quality, enables remote monitoring, it reduces the hospital visits and provides timely medical assistance, ultimately improving the patient safety and quality of life. So this is it for the introduction of healthcare IoT and the architecture of healthcare IoT. Hope you have enjoyed the video. Thank you.